Hello and welcome to your channel AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we're going to talk about Terraform, how to build and test a basic module in Terraform. Let's look at the objectives for today. We're going to create a Terraform project. We are then going to create a VPC module. We'll have a main project that is going to use the VPC module. And then using the main project, we're going to deploy and test the Terraform project. Things that we're going to build are given here. We'll have a folder called Terraform_code. Then we can have a main.tf file, which is basically a Terraform main file. Then we'll have a modules folder. And under the modules, we'll have files like main.tf, variables.tf, outputs.tf. TF is for Terraform. We can make another subfolder under this for VPC and then move these files. This is just to show you how the structure will be. So you'll have more than one modules. And the resources section here is just depicting that you have resources created after the Terraform has executed. One correction, this is under another folder under this module because we want to have multiple modules. So suppose you have a VPC module. So fold over here and then these files can be part of that VPC module. It's lab time. Let's look at the lab and see if we can learn something today. Okay friends, I have logged in to AWS console and this is your landing page. In order to run the Terraform, we are going to use EC2 instance. Let me open this EC2 into a new window. You can use EC2 from here or from the recently visited, or you can search EC2 in the search bar. I already have EC2 open into a new window. I see that there is one running instance. Let me open that instance. Now I can see this is a Terraform machine named as Terraform controller, and I am going to click on connect using EC2 instance connect. It opens another tab. Okay, I'm connected to EC2. Now in order to run any kind of Terraform execution, I need to check if Terraform exists or not. I will say Terraform version. This version may be different based on your installation, so don't worry about the version number. Now I'm going to create certain folder structure as we discussed. So I'm going to say make directory Terraform code cd Terraform code. I'm going to create one module, but because we can have more than one module, we will name it as modules. I'll create a VPC, another directory. I will say VPC because that's a module we are going to create. If you look at this, we are under Terraform code, modules, and one single module that we are going to create is VPC module. Now I'm going to use Vim to write the first file. So what all things we want in this first file? Let me paste one of the code. I'm going to explain this. We are saying the provider is AWS. Provider is a keyword to tell which cloud we are targeting to, and the resource is basically saying what resource we are going to create. This is AWS VPC resource, and that's a CIDR block for the VPC. Then under that resource, we want another resource which is of type subnet. So we are saying keyword resource, and the type of resource that we want to create is AWS_subnet, and this is where it is going to create. Its VPC ID is defined, and if you can see the naming convention, it's the name that we gave AWS_VPC in the previous resource. .this.id, which means once this VPC is created, its ID will be injected here, and the CIDR block is within this VPC CIDR block that we defined 10.0.1.0/24. Next one is basically we are saying AWS SSM parameter. Where are we going to have this? It is coming from Linux image that we're going to use, and I'm going to store this information. So I'll say write and quit, and you can see that as main.tf. I can show you it has been saved. Let's go and create another file called variables.tf, and this is primarily focused on fulfilling the variable that we were using in main.tf, which is var.region. So var.region, now we have this keyword variable and it's of type region, and we are saying the data type is string, default value is US East 1, and I will save. So if you can look at the previous one, you can see that this is var region, which means which region we are going to create. It will come from variable. Let me open variables.tf. It is coming from US East 1. So we have two files till now. Now we are going to create an output file primarily, which is going to be vim outputs.tf. Now what are we going to store over here? So we want to track all the values that are coming out. What are the values that are coming out? We need to get the subnet ID, because using the subnet ID we are going to host things in that particular subnet, and we need the AMI ID. So this is what we have in output. So what we are saying is the subnet ID which is going to be created once the resource is created under the VPC, the subnet resource. So you'll get an AWS subnet out of it. Similarly, the AMI ID will be coming out of this SSM parameter that we created. Let's save this file, and you have three files now. You have main.tf, outputs.tf, variables.tf. Now once we are done with this, I will go back. We are under Terraform code now. We have gone 2 steps back. This is the place where we started creating all these folders. So Terraform_code is the first folder that we created. Now in this we want to create a main file. So if you look at the modules is having only one module called VPC, and we are going to create a main.tf. So let me write vim main.tf. We want to use the module that we created earlier. I'm going to paste another code snippet that is going to give the code that we're going to execute. This is the main project Terraform project that we're going to run, but it is referencing a module that was created earlier. So I'll go through these lines. We have a variable, say main region, and the region that we are defining is US East 1. Then we are saying provider is again AWS, and main region is where this provider is going to create all the resources. This is similar to what we had in our module. Now we need to refer to the modules. So this is module resource type, and then we are saying which module. We created the module called VPC. There's a folder under modules which is VPC. We are saying where is this VPC? It's under module/VPC, and then we are passing this region information from our main file. Next one is basically saying what kind of resource that you want to create. We are saying we are going to create an AWS EC2 instance, and this is the name. Now, given the module that we are importing, we need to get an AMI ID. We are saying module.vpc.ami_id, and this ami_id is coming out of an output parameter over there, and similar, the subnet ID is also coming out of this vpc.subnet ID. These two are in the outputs file. And what kind of instance do we need? This is basically defining what is the instance type that you're going to use or that you're going to have for instance creation. This is T2 micro. Now I am going to write this, and I will show that it is saved. This is the file that we created, and let's go to module/vpc, and I wanted to show the output. So this is what we said. The outputs are cat output. It's not tf. So this is what we are referencing in our main module. There are two outputs that we are expecting out of this VPC module. Yeah, let me go back. Now we have a module under modules folder, which is VPC, and then we have the main file. We also want to write output of the EC2 instance. Once an EC2 instance is created, what is the private IP of that EC2 instance? If we want to show that, we'll say cat. I'll just create the file first, output, and then this is at the main level. Let me copy the outputs and I'll explain this. So now you have an output. We are giving it as a name of private IP, and description is private IP of EC2 instance, that T2 micro that we are going to create, and we are saying the AWS instance dot my instance dot private underscore IP, and I will write it down, cat outputs.tf. So this is here, and let me show you cat main.tf. You can see that this is the name that we referenced, my-instance, and that's what you referred over here, my-instance, and private IP is an attribute on that particular resource once created. And the first one is AWS underscore instance, which is basically this resource dot the resource that we created over here dot the property of that particular resource once created. So it's basically an attribute on the resource. Let me clear this. Now we have done quite a bit over here. How do we know that your code is good? So in order to check if the code is good or not, you can actually initialize and validate, but first of all I want to see if the code is written in the right format. So this Terraform FMT or format -- recursive means it is going to read all the files under this particular folder with TF extension, and it is going to format if the formatting is not in order. It didn't give any output, which means it was all in good order. Now before we can run the Terraform, we'll initialize, and what exactly it is going to do is it is going to fetch all the required providers. So when I do Terraform init, it is initializing and bringing AWS objects that will be, or the AWS specific resources that will be used for further execution of Terraform script. Now let me clear the screen again. Once we have done initialize, which is initial activity, one-time activity primarily, you can initialize again, validate, and execute your Terraform script. So how do I know my Terraform script is good and it is in good order, working as expected. I can run the Terraform validate. It is reading through the code and trying to see if there are any errors. So it is giving us success, which means the configuration that we have done, all the Terraform scripts that we have written is all valid. Now we can ask Terraform to tell us, if you execute this script, what exactly are you going to create? So we can click on Terraform plan, which is basically asking Terraform to give us a plan on what all resources you are going to create, or what all resources are going to be updated, and so forth. So it is going to take some time because it is analyzing all the resources that are required to be created. So let's wait for this, and you can see there's an output. If you look at the output, Terraform is telling us this is a resource, and these are some attributes. We are referencing private IP. These are some attributes. Once this resource is created, this will be known. Similarly, you have CPU options. You'll have other options under that particular EC2 once EC2 is done. Now you have other modules. So if you look at this, there's a subnet. Once the subnet resource is created, these are the attributes that will be available, like what VPC it belongs to, what are the IP addresses, all that CIDR block information, and other things. Similarly, you have the VPC information, and these are the attributes that you can refer once it is done. So you can see that it is saying plan to add basically three resources. I have the plan. I have validated already. So what is the next? We can say Terraform, because we had a plan. If we click with Terraform apply, it is going to ask me for an approval. But because I have already created a plan, I have seen that, I can just go and say auto and approve. This will execute the Terraform script, and you will have all these new resources created. So let it generate all these resources, and then we can go from there. Auto approve will remove the need of approving it again once Terraform is in execution mode. So you can see that it is creating all these resources that we requested. It has created a VPC, it has created a subnet, and it has created a instance. Now, once it has created the instance, see the private IP is printed because that is what we asked for in the output file. Instances, and you can see there is a new instance, and if I click on this, the private IP is 10.0.1.29, and this is over here 10.0.1.29. So that's a private IP. And you can see this is how your simplest vanilla Terraform script that was created using a module. One module, which is VPC, and then referenced that module outside in the Terraform project. And then from there, you created the VPC module that was created, gave you a VPC and a subnet into that. And using your external projects, which is over here, cat main.tf. In this external project, you reference that module that was independently created. So basically, you can reuse this module in multiple Terraform scripts. And over here, we requested Terraform to create all these objects, all these resources in US East 1. And from there, reuse this module and generate a new resource, create a new resource of instance, EC2 instance type in the module that we created. So using that script, we created this VPC. Now, once we are done with this, the last thing, or the cleanup you can perform, is very easy. But before that, I want to show that Terraform manages its state. So if I show you Terraform state list, okay, so I got this output. If you can see, the Terraform state list is saying that a VPC was created, a subnet was created, AMI ID pulled out of the SSM parameter, and then you have this instance created using that AMI. Now we are done with this particular lab, so I will go and type destroy. It is similar to deleting a stack. If I say Terraform destroy here, it is going to delete each resource that we created, which means it is going to delete the instance, it is going to delete the subnet, it is going to delete the VPC. So if I go over here and go to instances again, do a refresh. Oh, I haven't auto approved, so it is still asking for an input. So it is saying destroying my instance. I forgot to add auto approve, but yeah, without auto approve, it is going to ask you for a confirmation. Now it is destroying the instance. So if I refresh, it is shutting it down, still telling you that it is working on that, and it has destroyed the instance, destroyed the subnet and the VPC. If I go back here, refresh this, it's saying terminated. Okay, that's the end of this lab. Thank you so much for watching, and let me know if you have any comments. This is the end of the episode. Thank you for watching. If you liked the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you so much.